For circuit fabrication, LDI has been around a while, laser direct imaging, and that's definitely a plus. At these millimeter wave frequencies, the geometry has to be very well defined, and LDI is a big plus, and I know there's more fabricators using that, so that's a good thing.
Yeah.
But some of the additive things, like E-Surface, and I think there's a few others out there as well.
Averatek, we've had Averatek on the show, and I think they're doing some good work. So
Right. Yeah, so those are really interesting because at millimeter wave frequencies, what I found in some of the studies I've done is if the copper is very thick, or you might think of it as the conductor standing up off the substrate higher, you have more fields fringing in the air, and you can have more problems with what's called surface waves, or these waves kind of interfere with the wave that you do want. So when the copper is taller and more fringing and other things, it actually changes the performance of the circuit. So if you could have a thinner copper, not only does that help the circuit fabrication, because thinner copper usually means they can define the geometry a little better or more.
Sure.
Yeah, and then also thinner copper means that you should have less problems with these surface waves. And these surface waves are kind of it's a long, strange story, but the copper thickness does seem to matter. And then if you have circuit features that are coupled, like have two conductors side by side and they have electric fields coupled, the difference in the copper height of thick and thin does make a difference in how they perform. Again, at microwave frequencies, not a big deal. At 77 gigahertz, could be a really big deal.